Practice the recording. Hello friends, in the last session we were seeing construction of BFA. So here also in this session also we are going to I am going to teach construction of DFA only. But construction of DFA for the following strings over an alphabet A, B. What strings are there? The first one is strings of length exactly 2, strings of length at least 2, strings of length at most 2. So for these three problems, construction of DFA we will see in this session. Okay. So first one, construction of DFA for the strings of exact length exactly 2 or an alphabet A, B. So first, as I told you in the last session, first we need to write the language. So here the language is what? Strings of length exactly 2 or an alphabet A, B. So exactly 2 means we will get only 4 strings A, B, B. That's it. Because exactly 2. Therefore we will get only 4 strings in this language. Now, after writing the strings in that language, you need to check whether that language is finite or infinite. Clearly, we can say that it is a finite language. So, if it is a finite language, to construct the DFA, you need to take the maximum length string. So, here, but all the strings of same length, that's the reason you can take any length, any string. So, now we need to draw the skeleton for the greatest length string. So, the most important point is if the language is finite, you need to take the greatest length string to draw the skeleton. If the language is infinite, you need to take the least length string to draw the skeleton. Okay, so here all the strings of same length, let us say I am taking A string and for that I am drawing the skeleton. So this is my starting state A, and then so with that input symbol A, then I am reaching to the state B, and then A here also this is my final state C. So A this is my skeleton. Now I need to convert the states to convert into complete. So here A, B, C. So here can I give a self loop here? Like that you need to check, right? So if you give a self loop, there is no problem, or you can give here also no problem, because A I need to accept in the same fashion, BA also I need to accept. So that's the reason if I give here, you will get more than 2 length string. If I give a self loop here, you will get many number of B's followed by AA. But that kind of string is not available in the language. That's the reason if you give a self loop, problem occurs. So that's the reason I am giving with the available state B. If you give here either A or B, right? So if it is B, BA then followed by A, BA. It is there in the language. DFA is also accepting. So no problem, you can give here. Similarly, this state becomes complete now. So let us move on to this state. If you give a self loop, because this state is not complete, because for this state the input symbol B, transition is not available. So if I give a self loop here, again you will get a problem. What problem you will get? So either A or B, then you are getting some number of A's, but my string length is exactly 2. So therefore you cannot give a self loop here. So now give a transition with the available states. Let us say if you include here transition, one more transition, you can draw one more transition, or with the same transition give 2 symbols, no problem. So if you give here, is there any problem or not? So if it is A, here let us say I am taking in this transitions I am taking A, and here I am taking A accepting. So string is available. Similarly B, A accepting, that is also available in the string. Then B, and here also if you include B, that is also accepting. BB is there. So all the strings which are available in the language, all those strings are accepting. So now, but this state is not complete. So here, whether can I give a self loop here? If I give a self loop, definitely after exactly 2 length string, if you give a self loop, you will get 3, 4 and many lengths of strings. So you cannot give a self loop here. So that's the reason. Can I give a transitions with the available states? If you give a transition here, then 2 length, then you are getting 3 length. That means more than 2 length you are getting. So that's the reason you cannot give a transition with the available state either with B or with A. If you give, what happens means that length of the string becomes more than 2. So therefore you cannot do. So now what I need to do? Draw a transition, draw a new state and give that transition. Let us say here A. Now what happens is all these states are complete, this state is not complete. And again the state we can say it as previously also I told, this is a dead state. So here you can give here a self loop. That means after my 2 length strings If it is more than 2 length, I should reject. So because that my strings are not available in my language, therefore, so I am giving a dead state here with that in transition E. Now, so you can observe, take any string which is available in the language and check it whether it is accepting or not. You can check, and similarly for rejecting also. Last class we seen that one. So you can take, let us say, any string of length. Let us say I am taking BB. So now whether it is accepting or not, start with initial state A, B I am getting B. B I am getting C, which is a accepting state. Therefore B string you are accepting. Let us take any string which is not available. Let us say B I am taking. So then B So here I started with A I am getting B I am getting C A I am getting D. So which is not a final state. So that means you should reject. DFA should reject that. So that is the final DFA for strings of length exactly 2. So let us move on to that one. Strings of length at least 2. What it means? So you can represent string exactly 2. That's the reason I wrote here modulus of W is equal to 2. Now if it is modulus of W greater than or equal to 2, what it means? Exact strings of length at least 2. So just write language first. What is the language? So strings of length at least 2. So at least 2 means minimum is 2. So that means, so all those strings which are available in my exactly 2, all those are available here also. In addition to that, so you have any strings of length more than 2. And so on. So it's a strings of length at least 2 means strings of length 2, strings of length 3, strings of length 4, and so on so forth. You will get many more. So now look at the language. Is that language is finite or infinite? Infinite, right? So infinite means what? Take the least length string and draw the skeleton. So least length string is A. So that's the reason I am drawing the skeleton for least length string A. So this is my final string. So now I will draw the skeleton in the same fashion what we explained in the earlier one. The same fashion. So here also you can include the transition B. Here also you can include the transition B. Previously, to give a self loop in exactly 2 we got a problem. So because you are getting more than length 2 string, that's the reason we not given self loop previously. But now here in my language, exactly 2 length strings, 3 length string, 4 length string, all are available. So there is no problem to give a self loop here. Give a self loop A comma with the transitions A comma B. There is no problem. So this is the final DFA for strings of length at least 2. So if you have any problem, just take a string. So let us take, so previously I wrote A, previous string. So that is not accepted by DFA because it is not available in the language. Now look at in this, because it is of strings of length at least 2. At least 2 means more, 2 or more than 2, no problem. So here it is of string of length 3. So whether it is accepting or not, let us check. So here started with A, initial state A, so I am getting B, I am getting C, I am getting C, which is the final state, right? Final state, which is final state. Therefore, DFA accept this. Okay. So now let us take a string which is not available in my language. So at least 2 means, so not available means I am taking, let us say A. So strings of length less than 2. So that's the reason I took the length A. So now if you process this A, what I am getting? I am getting B. If you look at B, it's not a final state. Not final state. Therefore, so this is rejected. Okay. So this is the final DFA for what? And whatever method we are following. So I told you in the last lesson also, construction of DFA is nothing but the construction of minimal DFA. So if you are following this method, we will get minimal DFA only. So okay. So let us move on to the last problem. What is that? Strings of length at most 2. What strings of length at most 2 means? So now I am writing the language. Strings of length at most 2 means strings of length 0, strings of length 1, strings of length 2, because r equal to is there. At most 2, equal to is also 2. So therefore, here in my language, epsilon is there, A is there, strings of, so this is strings of length 0, this is strings of length 1, strings of length 1, and then strings of length 2. So here first we will write A, then AB, BA, B. So this is my language. Now look at the language. Language is finite or infinite? It's finite, right? So finite means you need to take the greatest length string and draw the skeleton. So what is the greatest length string? 2 is the greatest length string. So you can take any one. So let us, I am taking once again AA only. And one important point here is my language consists epsilon. My language consists epsilon. So therefore, if a language consists epsilon, my starting state and final state should be same. Not only here, anywhere, if a language consists null string, then my starting state and final state should be same. And I am not saying that final state is unique. There may be many more final states. Okay, so let us draw the skeleton, and here I am converting my starting state as final state. Why? I told you already. Because epsilon is available in my language, therefore starting state and final state must be same. And now I am drawing the skeleton for AA. So now for this A, and then I am moving to the state B, and then one more A, and this must be again a final state. Why? Because I should accept this AA, right? So this is the skeleton for AA, and I converted this as a final state. The reason I told you already, because epsilon is available in my language, therefore must and should my starting state and final state should be same. So that's the reason I converted. Now let us here, can I give a self loop? If we give a self loop, whatever problem occur in the previous problem, same problem occur. That's the reason I cannot give. You can give here, and similarly to the answer you can give. Now this state becomes complete, this state also complete, but this state is not complete. Now, if we give a self loop here, is there any problem or not? Definitely a problem. What problem? If we give a self loop here, you will get more than 2 length string. But in my language, maximum length string is 2 only. So that's the reason cannot give the self loop. Let us say if we give a transition with the previous states, available states. If we give us a transition with A, then again you will get a problem, because you will get more than 2 length strings. So those strings are not available in the language. Therefore, with the available states, transitions is not possible. So that's the reason give one more state. So this is my dead state, and here the input symbols are AB, and here also this state is not complete. That's the reason I am giving self loop. No problem here. So this is the final DFA for strings of length at most 2. And here let us look at now. So 3 problems I have given at a time. The reason is, so here strings of length exactly 2. How many states we got? Just look at exactly 2 length. So 1, 2, 3, 4. That means exactly 2. That's the reason we got 2 plus 2 states, which is what? 4 states. Finally, in the DFA, 4 states we got. In this DFA, at least length 2. So therefore, we got 2 plus 1, 3 states. And in this category, we got 2 plus 2, totally 4 states. 4 states. If we generalize, if the strings of length exactly n, we will get n plus 2 states. This is the generalization. And here, at least n, then we will get n plus 1 states. And in this category also, we will get n plus 2 states. This is also one of the important questions for GATE examination. Okay, so we will continue in the next session. Thank you.